Hey everyone, how's it going? Everyone hear me good? Excellent. So today I'm here to talk about efficiency engineering and taking our AWS bill and shoving it through the machine to optimize the hell out of it. I work for Stripe, and our mission is to increase the GDP of the internet. We do that by building economics infrastructure that allows big businesses, large and small, to accept payments around the world. I'm an efficiency engineer at Stripe, which means I spend a lot of my time looking at and being mesmerized by our AWS bill. At this point, you're probably staring at me a little slack-jawed, being like, why is this person on stage at an observability conference talking about costs? Well, I'm here to sort of make the case to you today that the cost optimization problem is the same thing as an observability problem. In fact, the observability team at Stripe is a sister team to mine, and we are best friends. We use all of each other's tools in order to get our jobs done. A little meta note about this talk. My market research shows that the key to a successful talk is lots of emoji. So there's about 109 of them in this talk for 50 slides. We're gonna move quick, all right? Hope you're ready. The central thesis of this talk is that in the cloud, cost and performance are aligned. All the resources we consume are metered, whether that's 756.2 gigabyte months of S3 storage or 0.52 instance hours of a C5.9x large. We can sort of choose to move the lever on cost optimization and performance optimization at the same time. Because of that, we can use a lot of the same tools that we use in our online observability stack. Hopefully, by the end of this talk, there's a few things you've taken away. The first is you're going to learn how to describe techniques to measure these costs at scale. We'll get into a little bit what scale means for us later on. Next, we're going to spend a lot of time on reserved instances. Reserved instances are these scary things from AWS that if you understand and use correctly will allow you to save boatloads of money. It's very important, so we're going to spend a lot of time here. And finally, we're going to talk about the technical and cultural challenges associated with building an efficiency program and how you can embed consistent thinking about cost optimization into your company. There's a chart on this slide, and that's kind of important because what we're doing here is providing observability for our cloud spend. Because cost and performance are aligned, we can use the same techniques we use to measure the P99 latency of our API to measure the use and effectiveness of our spend in meeting our goals for the cloud infrastructure. There's a lot of colors in this chart that are broken down by the AWS products that we use. I'm betting you can tell which one of them is EC2. So I mentioned that we were going to talk about how we measure costs at scale. So what does scale mean for Stripe? Well, we have hundreds of host types. These are sort of unique workloads that correspond loosely to like Puppet role definitions that run individual jobs and tasks on our infrastructure. We have a bunch of servers. And we've received in our history over 1 billion AWS billing line items. The hell is a billing line item? Well, just like in an on-prem world where you go buy an R640 DB server, AWS has SKUs for everything that they charge you. And they bucket these in hourly timestamps. So we have one line item for an hour's worth of S3 storage in a particular bucket. We have another line item for the number of X-ray traces we've stored as part of our tracing infrastructure. These billing line items are important because this is the source of our metrics. This is what we're going to use to divine all the insights about our bill. So how do we get observability for cost? What are our tools here? The number one thing we're going to consume is the cost and usage report. This is the detailed billing log of all of our interactions with AWS. Everything is on here on hourly granularity. This report updates daily, and you can and should be sucking this into your ETL and data warehouse infrastructure to make use of it. Let's break down a little bit what I mean by what's in a line item. There's a lot in this report, and it's important to focus our energy so we know what to look for. The three most important things that we care about are the usage type. This corresponds to that SKU I've been talking about. The SKU we're looking at here is an hour of time on an i3 4x large in the US2 region. The usage amount below is how much of this SKU we've consumed over the last hour. Here it says we consume 0.52 instance hours of it, so it looks like we just spun this guy up. Finally, we have the cost. Cost is like why we're here. It's what we're optimizing, so it's important that we know how to measure it. Here, that 0.52 instance hours corresponds to about 65 cents worth of cost for the hours time period. Important thing to note is this usage amount thing has units that depend on the type of SKU. So for instances, it's time. For S3, it's gigabyte months. For DynamoDB, it's reads and writes. This cost and usage report is a tad big. It has over 200 columns, and the number of columns is unbounded because you can put your own stuff in there too. Don't try and handle this on your own. AWS will give it to you in a format that's really easy to load into Redshift. Just do that and go to town with it. Write some SQL. Sort of tying those concepts from the bill back to the actual columns that we'll use. The usage type is this line item usage type column. The amount, similarly, is this line item usage amount column. But for the cost, we had this weird thing, this pricing public on-demand cost. What is that? Why use this sort of like notion of cost that doesn't align with the others? Well, AWS has several ways to measure costs. Most of them are lies that you should not trust. We're going to immediately cross out the unblended cost and the blended cost because these things depend on the vagaries of your billing setup, consolidated billing versus not, whether you have RI coverage, and how that fluctuates across teams, host types, products, and all this other junk. Ugh. Instead, we're going to focus on the public on-demand cost, which, similar to the name, is the list price you can expect to pay if you were just a random new AWS user that went to their public pricing page. The reason we choose to use the public on-demand cost as opposed to any of these more maybe exotic or specialized notions of cost is because it's one-to-one with usage. There's nothing we can do on the bill that alters how the public on-demand cost is reported. It's always the same based on the public pricing. This is really nice because it allows us to directly compare across teams, across workloads, across instance families, even across types within an instance family. This is super nice because it allows everyone to speak the same language. A dollar is a dollar is a dollar. One other tip I have hidden up my sleeve here is that you should tag all of your resources. This is sort of a data and infrastructure governance problem. There are a bunch of tools, some of which will be mentioned at this conference, that you can use to make sure your instances have the appropriate tags. Having tags is nice and useful because AWS can pass through user-defined tags to your cost and usage report. This is the unbounded nature of the report that I was talking about before. If you choose your tags carefully, you can use this denormalized data in the metrics stream to allow you to slice and dice your data in interesting ways. These tags on the screen are my recommended set. They include the VPC your resource is in, the team owner of a resource, the cost center associated with this particular instantiation of the resource, and the host type, which is the workload type that we talked about earlier. These sort of go in increasing levels of granularity, and we include them on every record in the cost and usage report for the same reason that you denormalize tags into your normal observability metric time series. Querying normalized data is hard. While I can join the cost and usage report instance ID to AWS config to figure out what VPC a resource is in, it's not really a productive use of my time, and I'd rather pay the few bytes in Redshift in order to make this query much easier to iterate on and much easier to divine those insights for my finance team and all of the infrastructure engineers that might consume it. These tags also allow us to attribute spend to different workloads, teams, infrastructure, and products, and are what's part of a process called showback reporting. Basically, by attributing spend to individual components and teams, we can show them how much they're spending on the infrastructure, which they can then use to optimize their use of the infrastructure and make the products that they're trying to support more margin positive. Now that we sort of have looked at the cost and usage report and have figured out what's in it and what's important to us, we can use it to answer some new and interesting questions like how many servers do we have and what type of them are they? This graph right here is a month snapshot of all of the servers in our fleet, bucketed by hour. One interesting thing to note here is that the dimension on the legend on the side is instance family and not instance type. The reason we do that is to cut down on metric cardinality. If we had to deal with every instance type and every instance size, we kind of have like an n-squared classification problem, which is kind of gross, and we'd like to avoid that. Just like metric cardinality is an issue when you're ingesting metrics, SignalFX or Datadog, you also want to make sure that you cut down on your metric cardinality when you're measuring your costs. One interesting thing to note is this dark purple line at the top is the use of I3s over time, and this light sky blue line below it that keeps creeping up is R5D. We'll talk about this later and how we got here. How are we able to make this simplifying assumption where we're just able to cut out all the instance size trickery that might have prevented us from looking at the true usage for our instance families? The way we've done this is through this synthetic measure of size called an X-large equivalent. Basically, we can take advantage of the fact that costs on AWS instances scale linearly. A i3 4x large is twice as expensive as an i3 2x large. So if we sort of normalize the size of our fleet to X large, this allows us to measure costs in a simpler way with one less dimension. AWS also exposes a normalization factor in the cost and usage report. I think their base size is small. We choose X large because all the instances that we use have an X large size, and it's just easier for us to grok. Again, these simplifying assumptions we're making with the reporting to cut down on the cardinality allow us to make cost and usage comparable across different workloads. Now, I can look at all of my compute instances that are running on C5s and see what the cost and usage vary across different teams that may be running different individual host types. That was a whirlwind tour of the cost and usage report. I hope y'all are with me. There'll be time for questions later, and I'm going to be tooling around the Slack channel associated with this talk if y'all want to dive a little deeper into that. But on to reserved instances. To sort of level set, a reserved instance is a contract that you enter with AWS that gives you a discount on a resource in exchange for a commitment to use that resource for a given length of time. It's a little abstract. Basically, it means I can say I'm going to use a C5 9x large for 3 years, and AWS will cut the cost of it by 50%. It's a pretty big deal. We believe that of all the savings you're able to eke out of AWS, about 50% of them come from reserved instances. Really big deal, worth understanding how these work so you can leverage them in your own use of AWS. Additionally, on a per instance basis, the discounts can be up to 52%. I pulled this number by looking at the excellent EC2 instances.info and looking at the cost of a C5 X large instance with a 3-year, no upfront convertible reservation. It's like a lot to unpack there, so let's rewind and talk about that. C5 X large, we're using the X large size because we're doing that X large equivalence thing that we talked about before. C5 is a compute instance family. It's the newer version of the compute family. 3 years is the contract term. So once we purchase the reserved instance, we're committed to paying for it for 3 years. No upfront is the pricing plan. This means that we don't pay any money upfront at purchase time in order to use this service or use this instance, and we pay a effective hourly rate over the 3-year term. And finally, a convertible RI means that at any point over the contract term, we can exchange this C5 X large reserved instance for any other type. This means if suddenly we become really disk heavy and we want an R5 or an i3 X large to run this thing, we can. Or if at reInvent AWS announces the C6s, we can upgrade to that as well. We feel like this combination of like flags here gives us the most optionality and savings trade-off. But it seems like there's a lot going on here. Like, how do we buy these things? It's like pretty non-trivial, a lot of decisions to make. And that's compounded by the fact that RIs are sort of like at the intersection of cloud strategy, bin packing, capacity planning, infrastructure and product engineering. There's a lot to consider. There's a high dimensional search space here, so we want to figure out how we can cut that down. These are the dimensions of a reserved instance purchase. There's a lot of them, by my count 13. That's a lot of decisions to make every time we want to buy something. Like, normally AWS makes it really easy to buy stuff from them. Why is this so hard? And the answer is because it makes them less money. These orange ones on the top here are all of the decisions that AWS asks us to make. Like, we make the API call, or we clack, clack, clack on the mouse in order to make the purchase in the console. We need to fill out and check all these boxes. The stripe-colored ones on the bottom are the ones that we as a company feel like we need to answer in order to feel comfortable making a purchase. Particularly want to know when we should buy these things and who's going to make the purchasing decision. But not all hope is lost. We know some stuff at the beginning. Hopefully, you know what region your servers are in. Hopefully, you know what OS they run. And hopefully, you know whether or not you use shared or dedicated tenancy instances. So we can lock in 3 things right off the bat. We're doing great. The next sort of Gordian knot of a decision we need to make is to use regional scope. And I'll get into a little bit what this means. When AWS first announced reserved instances, they were only zonal. This means you decided to purchase some reserved instances. Those instances were tied to a single AZ. You couldn't float between them. But in exchange for that lack of flexibility, you got a capacity guarantee. If I reserve 50 C3s, I'm allowed to always assume that that capacity will be available to me, whether or not I have spun up the instances or not. While a nice feature, this doesn't really work for us because it means that we're inherently wasting resources in order to use this feature. Capacity assurance only works at the edges. You only can reserve additional capacity if you're not already using all that capacity with the servers you already have running. Otherwise, you're just paying for capacity assurance for the servers you've already spun up. It's not super useful. One of the goals of my team is to make sure that we never have unutilized reserved instances. We view it as throwing money away. So we feel comfortable sort of not caring about capacity assurance. So how do we get rid of capacity assurance if we don't feel like we need to pay for it? The way we do that is by flipping the scope of the reserved instance from zonal to regional. This means that now our reserved instances can float among all the AZs in US East 1, which is super nice because we might have elastic workloads that move between regions. We don't want to be bean counting the servers and make sure we're doling out the right instance allocations among the AZs. I think there are like 6 or 7 of them in US East 1. That seems like it would be a bad time. The other thing that instance size flexibility gives us is the ability to choose the X-large size that we've been doing before and have it apply to the reserved instances themselves. This feature is called instance size flexibility, and basically it means I can buy 100 C5 X-large reserved instances and have it apply to any combination of C5s that I might have in my infrastructure. This is super nice. We're further cutting down the dimensionality of the search space. So we've locked in another 3 more dimensions: the scope, the capacity assurance, which we don't care about, and the instance size. We're only going to use X-large. The next thing we want to consider is, phone a friend, call for help. And the reason we're doing that is because reserved instances are not just an engineering decision. They're a finance decision, too. We're committing to spending lots of money over the next 1 or 3 years, so it's important that sort of like the business people kind of like are involved in this decision. The contract term, the ability to exchange versus trading off for the maximum discount, and the decision of what payment plan to use all depend on the financial health of your company, your appetite for vendor risk, and your willingness to make capital outlays, all of which the finance team is best equipped to solve. So we're going to delegate to them, and we're going to lock in 3 more dimensions. All right, now here's the fun part. We haven't really been doing much engineering work up to this point. We've kind of just been like figuring out the process and making sure that we set up the right guardrails in order to make good decisions here. But now we need to answer the hard question of, when do we buy these things, and how many of them do we need? The way we do that is with a batch job. We take this cost and usage report, which is our metric source, and we run an ETL nightly that sort of takes a snapshot of the entire fleet, figures out what our baseline RI usage is for the previous day, and compares that with the actual usage that we observed the previous day. Then we sort of mash these two together and figure out whether or not the numbers are aligned with our coverage target. What's a coverage target? I find it easier to explain this with an example. I'm going to go back to my favorite C5 instance family, and we're going to say we want on a reserved instance to apply to 90% of the C5 instances in our fleet. This means we need to figure out how many servers in the fleet we can purchase a reserved instance for, which may vary based on dynamically scaling workloads or scheduled ASG spin-ups and spin-downs. Once we figure out that number, we'll figure out if the target is higher or lower than the amount that we actually have and fire an alert for a purchase. This concept of having a coverage target is really nice because it's a way that we can measure the effectiveness of my team. We know whether or not we're throwing money away by having too many instances reserved, or if we're not saving enough by being below our coverage target. KPIs are good. That's how we measure our effectiveness, and we can make sure that we're doing the right things and focusing on the right problems. So once we mash the cost and usage report together to find out if we're exceeding our target coverage or not, we fire an alert. And this is where sort of the automation ends. We don't go into our ETL stack and fire the AWS CLI call to make the purchase via the command line, because that sounds terrifying, and I do not want to get paged when that goes sour. So instead, what we do is we fire an alert into our Slack that a purchase needs to be made, input the amounts into an internal admin tool, and send a manual approval request to the right people, most notably finance, who can make sure that we're in line with our budget for the year. We want to make sure, though, that we're not constantly paging. The fleet generally goes up in size, so if we're not careful, we might be getting paged every day that we need to purchase more reserved instances. And the way we work around that is by having sort of this acceptable band of plus or minus 5% around our coverage target. That means the fleet can go up and down a little bit, and we can say that this is just business as usual and we don't need to execute a purchase, which takes a little bit of time and interrupts the runner from doing what their normal work is. Once we do go outside that coverage band, then we trigger a purchase or a conversion, and everything resets itself the next time the ETL runs. Awesome. We're almost there. Got one left. This pesky ownership thing. How do we handle it? To know a little bit about how to best assign ownership of this tricky problem, you need to know a little bit about how Amazon allocates reserved instances. And the crazy thing is that these are a global resource across every account in your consolidated billing organization. That means even if you have isolation between teams and products based on AWS accounts, that doesn't help you with the reserved instances, which may end up getting applied all to the account over here or all to the account over here. It makes attribution really difficult, and it makes a sense of shared responsibility even harder because no one wants to own something that they might not see the benefits of. In order to fix that, we've centralized the ownership of this decision into my team, into the efficiency engineering team. We buy reserved instances for all of Stripe and are responsible for making sure that the button gets pushed at the right time so we don't drop money on the floor. We did it. We got all of our 13 locks up there. It looks pretty good. Y'all are experts in purchasing reserved instances. Go forth and buy. On to the next. So in the goals slide, we talked a little bit about building a culture of cost competency and what it means to embed these processes and tools into your organization so you don't immediately slip. It's pretty easy to just one time make a cost optimization push and make sure you cut the bill by however much you can. But if you don't build these processes into the process of feature design, product development, and infrastructure development, you're just going to end up in the same place 6 months later, which is not super useful. We're going to take a look at some both technical challenges we've faced and how we've addressed them, as well as some cultural optimizations we've made along the way. So just like the reserved instance problem is a global optimization problem for all your AWS accounts, we view cost optimization and cost management as another global optimization problem. We want to do the whole program optimization of our product and infrastructure engineering orgs to make sure that we are aligned on spending the right money on the right infrastructure. Again, this is something that my team, Efficiency Engineering, owns, and we treat the entire cloud stack as both a white and a black box and dive in there and figure out what projects we can fix. Once a quarter, we work together with our TPM organization to come up with our top 5 projects that would help us optimize costs and sort of work together to help prioritize these efforts across engineering. When we're dealing with this whole program optimization, there's sort of 3 questions we might find ourselves trying to answer: which, when, and where. Let's talk a little bit about which. I've got this package on the slide here. It says instance right sizing. This means that we're trying to pick the right server for a workload. This is like very much Goldilocks, but instead of bears, we've got servers. It's like very oriented for a children's bedtime story. It's super good. So we've got all these servers. We want to make sure that we're selecting the right ones. And the reason we can care about this using our observability stack and our cost stack is because cost and performance are aligned. We keep coming back to this. This means that if our servers are too small, we're wasting on the performance axis, and if they're too large, we're wasting on cost. We want to find the size that's just right. The cost and usage report gives us a global inventory of all of our SKUs by workload once we've incorporated our tags into the report, which makes it easier to see if we're using the right instances for these workloads. When we work with the TPM org to come up with a list of cost optimizations, this is a very easy area to focus on. A good example of this is some work we did on our Hadoop infrastructure. If you remember back to the chart of all the instance families, I3s were going down, R5s were going up. The reason we did that is because we discovered we didn't need the disk capacity that the I3 instances provided because we were using S3 backed storage for our HDFS. Instead, we switched to R5Ds to get us a cheaper cost per core and similar memory usage, which allows us to get faster and cheaper cores, and that's a win for everyone. Another easy technical win we had was to do with auto-scaling our CI infrastructure. I'm sure you all know it's almost a meme at this point that the cheapest server is one that's turned off, so we're going to turn off some servers. It's going to be great. We have several global engineering offices around the world, and we did a follow-the-sun pattern with scaling these instances up and down during the day, especially making sure that we had local resources available for engineers in the time zones that were in the afternoon, which is when people are trying to push their commits in order to get home for the day. To make this happen, we had the CI team, the finance team, and the efficiency engineering team align and collaborated to help balance the trade-offs between cost and quality of service for our engineering organization. Again, cost, performance. How do we trade these off against each other? The last bit that was kind of a fun project was, again, on our Hadoop infrastructure, trying to minimize the cross-AZ network traffic that we were sending. We don't use AZ-aware HDFS, so having clusters span multiple AZs doesn't get you any more redundancy. You might end up with 3 copies of the block in the same AZ, which is not great. But it does get you a whole lot of extra costs because HDFS is chattering constantly across all of these AZ links, which is not cheap. So we consolidated the clusters into a single AZ, and we're able to cut our costs for this infrastructure in half. Amazing. How did we make this optimization? How did this come to light? Well, an engineer was looking at a dashboard embedded in their signal effects that used a offline computed copy of the cost and usage data, which we put into our online metrics repository, which means that teams can have their cost data and their online data in the same space, which we found super powerful to enable teams to self-serve and use the tools that they're most comfortable with. There's some cultural aspects here that we need to talk about too. Like the system that we've been talking about is more than just code and infrastructure. We need to talk about the culture of our organization, and we need that cost optimization mentality to be a first-class concern when we're designing products and infrastructure. How do we do that? The first is with scorecarding. Basically, we take this metrics repository, this cost and usage data, and compile it into several pre-computed views that allow teams to more easily inspect their spend. The first of these that we compute is a monthly snapshot for each team and each product's consumption of shared infrastructure services and AWS spend. This means that even though the database team manages all of the MySQL infrastructure, we can sort of shard those costs out among all the teams that depend on those MySQL tables. And sort of like cascade the attribution down until we have figured out who owns what. The next scorecard we create is a velocity-triggered nudge that on a daily basis looks to see if a team's spend has changed rapidly over the course of the previous couple of weeks. If it has, we send an email off to their manager and their tech lead in order to make sure that someone is aware that things are changing in a way we didn't expect. One kind of cool, non-obvious thing here is that my team can manipulate these scorecards in order to get the behavior that we want from the infrastructure org. So for example, say our orchestration team does a lot of hard work and and deploys a brand new Kubernetes cluster. We have some machine learning infrastructure running on one that's 2 versions behind, and we want to incentivize them to upgrade to it. Well, we have 2 levers we can pull. We can either make the new infrastructure artificially cheaper or make the old infrastructure artificially more expensive. Either way, we can kind of use the cost data that we have to trend the organization to make the decisions that we want them to make. Product attribution is sort of the next natural step here. We want to continue these hops all the way down to the actual products that infrastructure and product code is supporting. The MySQL database is great, but it exists to serve our payments infrastructure, and that's either making money, yes, or not, oh no. But these sort of down the pipeline attributions allow us to make good business decisions about which of our products are margin positive or not, and have knock-on effects elsewhere in the organization. The sales team might use this data to more effectively price deals, or the marketing team might use this to tailor their go-to-market strategies. Being aware of costs on an organization level is a very powerful tool. And finally, I want to talk about something a little more fun. In our global metrics dashboard that everyone at the company can see, we have a page that I've called the Saveometer that tracks every cost win that has ever happened around the company. Puts a nice big number on the screen in front of people, lets them pat themselves on the back, feel very good about it. And the reason we do that is because we want to encourage this sort of behavior org-wide. Seeing all the good work that all of us at Stripe have done is highly motivating to make sure this type of work happens in the future. Ta-da. Sort of recapping what we've learned here today, we are heavily utilizing the cost and usage report to track, categorize, and attribute our spend. This is our metrics repository, and we want to make sure we use it to generate all the reports and online metrics data that we can. Finally, we talked about reserved instances and how they can save us 50%, and we should be very much trying to use these, and how to take both technical and cultural initiatives in order to make good on the promise of optimizing costs. Thank you very much. Hope to see you. I'll be hanging out in Slack.